Hi, Violet. Let's see what we got going here. So the idea here is when the water is sitting up here at the top, and when it goes down the spillway, it is going to not have 100% KE at the bottom. And the reason that is because it is going to lose from friction thermal energy 30%. So it won't be 100% KE. The KE will only equal 70% because it's lost. It's almost like having the brakes on as you go down the hill. Now, when it drops this way, we're going to say there's no friction on the way down, at least, because it's dropping straight down. And so it will have 100% KE available to make energy, to make electricity. And that's the difference, is this will be going full speed when it hits the turbines inside here. And then this will be slowed down. And you kind of want it to slow down because when it's going down here, if it has full force, it can actually undermine your dam. You want this to slow down. So these are usually actually not just a real smooth surface. They're usually made with little ribs in the concrete. And so the water goes like this and it goes down slowly. It just acts to slow them down. And so when it hits the base here, it's not just like a water slide. So that's why you have um, the two different graphs. So if you have potential energy at the bottom, there's none. Potential energy at the bottom, there's none. So these are both at the bottom, but this is the hydroelectric, and this is a spillway. And the spillway is supposed to slow down. So thermal TE will be 30%, and then KE will be only 70%. So it's only going 70% of the energy, as here it's 100% of the energy here. And here this is 0. So this is KE, TE, and ME. And these three things have to add up to equal your total, which is called ME. And these three things have to add up to equal your total, which is ME. So when you do these two equations, it's not, it's, so when you do these two equations, when you're doing KE equals 1/2 mv squared to find the velocity, then whatever this number is, you put in there. You don't put in 70%. You put in 70% of whatever it is. So if it's 1,000, then you put in 700. If it's 10,000, you put in 7,000, right? And then for this one, you put in 100% of it. If it's 10,000, you use 10,000. If it's 1,000, use 1,000. And in the end, we're trying to find the V, and the V here will be slower, and the V here will be faster, because this is 100% speed and this is 70%. Now, some students will find this, and then they'll take 70% of it to find this velocity. You can't do that. And the reason you can't do that is because it's not a straight proportion because of the square. So anyway, if that solved your question, then awesome. If it doesn't, then let me know. And